This is the first video in the series Library Functions of the Character class. Now it's about to rain now, so you might hear some thunder, some noise of thunder, like for example now. I'm really sorry regarding that. It's quite warm in here, therefore I have the windows open and and you're probably hearing the sound of the thunder. Right, so I'm really sorry about that. So please ignore that for a moment and please lower your volume if you can on your phone. Now, before we begin with the library functions, I would like to revisit some of the topics that you have covered in class 9. So the topics includes first the ASCII codes of the letters, numbers, and space, followed by the relation or the similarities between the integer or int and the char data type. All right. So let's begin with the ASCII codes first. Now, before I dive into the ASCII codes, before the ASCII codes of the different letters and numbers, I would like to make one fact clear. Our objective is not to memorize the ASCII codes of every single letter or every single character. If you know the range of ASCII codes of letters and numbers, we are good. We are in a better position to write our codes and to answer the output prediction questions that are asked in terminal papers or in ICSE papers. All right. Now, before I begin with the ASCII codes, I would like to mention two facts first. Now, the first fact being that the English alphabet consists of 26 letters. Now, you must remember this number very carefully. So, 26 letters are present in the English alphabet. Moreover, in our decimal number system, we have 10 digits. Now, why am I stating this obvious facts which you already know? Because we will use these facts to calculate the ASCII codes. All right, let's see how we do that. So here we have the uppercase letters, the lowercase letters, the numbers, and the space. Let's start with the ASCII code of the space. So space has an ASCII code of 32. All right. So this is just the single ASCII code that you need to memorize. Well, this and another one. All right. Now you might see, you might find it awkward that I have written this odd of a character in enclosed within single quotes. Now it's difficult for me to show you a space on the whiteboard, on the blackboard, right? Therefore, this character denotes a blank space. All right. You wouldn't find this character on the keyboard, nor would you write this in your program, right? But to denote that there's only a single blank space that is enclosed within the single quotes, I'm going to be using this character, B, with a strike in between. All right. Okay. Now, apart from the space, the uppercase character A has or begins with the ASCII code 65. All right. Now, we can calculate what the ASCII code of Z will be, because starting from A through Z, the ASCII codes are ordered in sequential manner. For example, as 65 is the ASCII code of the uppercase letter A, B would have an ASCII code of 66, and then C would have an ASCII code of 67, and so on and so forth. All right. Now, we already know that the English alphabet consists of 26 letters. All right. Now, because it contains 26 letters, we can easily calculate the 26th number starting from 65. Now, some of you might be confused at this point. Now, how should we calculate the 26th number? Well, to alleviate or remove your confusion, I have a small example. So, starting from 2, which is the 5th number. So, if we start writing the numbers from 2, so that's the first number, that's the third number, that's the second number, that's the fourth number, that's the fifth number, and this is the sixth. I'm really sorry, and this is the fifth number. All right. So starting from 2, the fifth number is 6. Now the question comes: how can I arrive at this number directly by using some formula? So the formula is pretty simple. You see, the formula is 2, the starting number, plus which number do you want minus 1. And if you calculate this, you're going to arrive at 6. This is the formula that we are going to use to calculate the ASCII code of the capital letter Z. Now, which is the 26th number, starting from 65. Let's apply the same formula again, all right? So starting from 65, the 26th number would be 65 plus 26 minus 1. Now, if you calculate this, you're going to arrive at the number 90, and that is the ASCII code of Z. All right? Okay. So the only ASCII code that you need to remember is the ASCII code for capital A and the ASCII code of space. Now, using these two, we can calculate the ASCII code for the characters that have been mentioned over here. For example, to calculate the ASCII code of A or lowercase letter a, what we can do is we can add the ASCII code of space. So 65 plus 32 gives you 97, and 90 plus 32 gives you 122. So this is the ASCII code range for the lowercase letters. 97 is the ASCII code for small a, and 122 is the ASCII code for small z. Now, there's another thing that you need to memorize. I'm really sorry. That is the ASCII code of 0. Now, 0 has an ASCII code of 48. All right. And we already know that there are 10 digits in the decimal number system, starting from 0 through 9. So, which is the 10th number starting from 48? Pause this video, think about it for a while, and then play the video again. Resume the video again. All right, so I hope you figured it out yourself. So let's calculate that. So the 10th number starting from 48 would be 48. Let's remove this. So it would be 48 plus 10 minus 1. And if you calculate this, you're going to arrive at 57. All right. So three things. There's just three things that you need to memorize. The starting ASCII code of the ASCII code of capital A, the ASCII code of 0, and the ASCII code of space. And with that, you can calculate the ASCII code for all the other characters, or all the other letters and numbers, that is. Now, what you've seen here is that to convert an uppercase letter to a lowercase letter, we add 32 to it. So if we have the ASCII code of capital B, and if I add 32 to it, then I'm going to get the ASCII code of the lowercase letter b. Similarly, if I have the ASCII code of lowercase b, then to arrive at uppercase b, I'm going to subtract 32 from it. And this is how we convert from uppercase to lowercase and lowercase to uppercase letters, respectively. All right. Now let's move on to the second topic that I'm about to revisit. Now, the second topic consists of the similarities between int and the char data type. Now, here I have 4 cases, and this 4 cases or this 4 code snippets would showcase the similarities between int and char data type. Therefore, let's start with case 1. So in case 1, we have a character variable ch to which we are assigning the uppercase letter a. Now, if we simply print out the content of this variable, the output that we are going to get is A. All right, that's pretty simple to understand. Now, let's move on to case 2. Now, in case 2, what we are doing is we have the same character variable ch to which we are assigning the uppercase letter A. Now, instead of printing the content of the letter directly, what we are doing is we are typecasting the content of ch into an integer type. Now, what do you think this should output? Pause this video for a second and think about it. All right. So I hope you did pause the video and I hope you figured it out. So converting a character to an int yields the ASCII value of that character. So we know it from the previous slide that the ASCII code for capital A is 65, and therefore converting a character variable or a character to an integer yields the ASCII code of that character. Therefore, the output that I'm going to get will be 65. All right. Moving on to the third case. Now, in the third case, what we're doing might seem a little strange to you. We are assigning a character literal. Well, this is a character literal. Character literals are enclosed within single quotes. Now, we are assigning a character literal to an integer variable. So what do you think would happen if I print the content of ch? Do you think this code snippet is valid at all? What do you think? Pause this video and think about it. All right. Now to answer the first question, this code snippet is valid. If you write the same code snippet in a program, this would definitely work. I can assure you of that. Now, about the output, you see, character data type is smaller than the integer data type in terms of size as well, because character data type has a size of 2 bytes and integer data type has a size of 4 bytes. Moreover, in the data type hierarchy, char comes before int. Therefore, its precedence is less than int. Thus, because char is a smaller data type than an integer data type, therefore an integer data type can accommodate a character literal. But when you assign a character literal to an integer type and you print the content of that variable, you will directly print the ASCII of that variable. All right. So if you run this code on a computer, you will find that the ASCII of small a, which is 97, would be printed. All right. It requires no typecasting or explicit typecasting, I must say. This is an example of an implicit typecast. All right. Okay. Or type promotion or coercion. All right. Now let's move on to case 4. Now in case 4, we are assigning a character literal to an int, and we know that this is a valid code. Now, if you were to convert or typecast that the content of that variable to a character, what do you think would be printed? Simply the character which was assigned to it in the first place. So small a would be printed if you convert an integer to a character data type. Right? So this concludes the similarities between int data type and char data type. And that's it for this video. See you in the next one. Bye for now.